you can see my PPT?
Yeah, it's visible. Yeah, it's visible.
Okay. So hi guys, this is Shelly here, your programming co-lead, and I am joined with Lennon, who is also your programming co-lead. And we're going to take a session on Intro to Machine Learning. This is going to be a very beginner-friendly machine learning course, because honestly, I wasn't sure how many of you were experienced in machine learning and stuff like that. So yeah, this is also going to be a pretty short session. We did say 90 minutes, but then most of the time is just going to be talking with you guys. So 1 minute, I think somebody tried to join. Okay, 1 minute. Lennon, I made your co-host. Can you just add people as they come?
Okay.
Okay, so yeah, that's just it for the introductions. I'll get started. So this is what we're going to cover today, very basic stuff. So for the first, we're going to go over what machine learning is. Then we're going to talk about the difference between AI, ML, deep learning, and data science. Then we're going to go and talk about types of machine learning. And lastly, we're going to talk about data analytics and the tools you want to use in data analytics. Okay, so before I show my answer, what is machine learning? What do you guys think? What do you guys know about machine learning?
It is like you are given some inputs and some outputs. So you are like mapping a function from the input to the output, finding out the function.
Okay.
Or we can say like an algorithm is covered. Hello.
Tell.
We can say like an algorithm is given a set of data, and we'll be training the algorithm with those set of data, and it can predict the future result based on the previous set of data.
Okay. That's a decent explanation.
So basically interacting with the model such that you can get a communication between the user and the interface so as to, train the data in the set, and so that we can get the particular result as Thirmal said.
Okay, fair enough. So I'll get into what I think machine learning is. So again, machine learning is kind of an umbrella term for solving problems where the machine discover their own algorithms. Now, what does that mean? When we are just programming normally, right, we have to use conditions. We have to kind of program almost every single condition. What will happen? What should the program do when this happens or that happens? And that's not always feasible for us. So what in machine learning, what we do is the machine itself discovers the algorithm on their own. Now, how do they discover it on their own? That's using a lot of data. Right, so we give the machine the data. The machine kind of learns how to solve this this data by using algorithms, and we don't actually need to tell the machine what to do. So that is just the basic definition of machine learning. Here, the primary word you will use is without needing to be explicitly told. You don't explicitly tell the machine, you don't explicitly program what you need from the machine, and the machine kind of figures it out itself. So the examples of machine learnings is ad recommendation. So example, the ad recommends you the ad recommendation you get on YouTube or Instagram. So example, you went and searched about perhaps going on a vacation. You search Manali perhaps, and then you'll get a lot of ads perhaps from Make My Trip or other these trip advertising companies, right? That works again because of machine learning, because the machine sees okay, that you start searching about Manali or wherever you want to go, and then it will just recommend you ads on the basis of that, right? And then there is email and spam filtering. So what that means is, there is a spam box in your emails, right? You'll see how does the machine kind of figure out if a mail is spam or not. Again, that is done because of machine learning. So companies such as Google or Yahoo or Rediff, the people who have mails, they have very good algorithms to figure it out because they have so much data. Like they have the model has been trained for so long on so much data. It's also very good at predicting what spam is. Then you have Google Translation and speech image recognition, and last but not least, traffic prediction. So again, Google Maps, for example, like if you want to go to the mall, perhaps you can see multiple ways you can go to the mall and the time it takes and all that stuff. Again, that is machine learning. So now, AI versus machine learning versus deep learning versus data science. These are the 4 terms you guys must have like learned or you must have heard about. So what do you think is the major difference between all 4 of them? Like what separates all 4 of them that we have these 4 different words? Anything, you know, you don't have to be correct.
In terms of interpreting the data.
How so?
I'm not sure.
So no worries. Anybody else? What about the people who have experience with machine learning?
I only have 1 day experience, I guess.
Oh, 1 day experience.
That's
Chalo,
because of
koi
hackathon
baat
only.
nahi. Hackathon, no.
Smart
Hackathon is
India
a great way
hackathon.
to learn. Yo, that's a great way to learn, I'm telling you. Okay, no
Actually,
worries.
actually, any YouTube tutorials they haven't even hadn't even taught me AML or like deep learning data science. And all. This hackathon
Okay,
only
no
actually
worries.
taught me mainly.
Okay, no
Yeah.
worries. So this is a Venn diagram. You must have seen multiple times, but you probably don't know exactly what that means. Can you let the person in?
I've let them in.
Okay, fair enough. Thank you. So we'll start with artificial intelligence. So artificial intelligence and machine learning. So machine learning is a subset of artificial intelligence, right? Now, what does artificial intelligence mean? It means that you're putting intelligence artificially onto a machine, right? And machine learning means you're basically making a machine learn how to do one task. That's mostly what we do, right? But how is machine learning and AI different, right? Now, when we talk about intelligence, the concept is a little, I would say, abstract. It's a little open-winded. There's multiple ways you can describe intelligence, right? Some people might even consider emotional intelligence while considering intelligence, right? So, but you can't make a machine emotionally intelligent, right? That hasn't happened, and that's not really possible. Like, how can you code out like emotions, right? So that's why artificial intelligence is kind of the bigger circle you see, because intelligence itself is a very broad concept. Everybody has a different definition of intelligence. So if you make a machine learn how to do a specific task, obviously that is intelligent, like that machine is intelligent. But then is learning how to do one task, is that the only thing that comprises intelligence? No, right? Like there are multiple things that comprise intelligence. That's why machine learning is a subset of artificial intelligence. So artificial intelligence, as the name suggests, is programs with the ability to learn and reason like human beings, while machine learning is algorithms with the ability to learn without being explicitly programmed. Now, deep learning is a subset of machine learning. So what deep learning deals with is artificial neural networks. So neural networks is something you must have learned when you were young, right? We have neurons in our body, right, in the nervous system. For example, if we touch a stimuli, if we touch a hot object, then that kind of signal travels from your hand to your brain through just bunch of millions and millions of neurons, right? That's actually quite similar as to how deep learning works. There are artificial neural networks, and the deep learning kind of mimics how things work in our actual body, in our actual nervous system. So deep learning you'll use mostly for things such as image recognition or speech recognition or stuff like that, right? And last but not the least is data science. So data science is actually a cross-disciplinary field. Now, what that means is not just about making models, it's also kind of learning insights from data itself. Now, you might wonder, like, what kind of insights can we see from data? You can learn a lot of things from data. So, example, if you get data, you can get to know what the mean, median, mode, how vast is the data, how's the distribution of the data, like is it normal distribution or whatnot. Like there's multiple things you can learn from a data, right? So actually organizations, companies actually use data science or data analytics a lot in their own company to figure things out, because modern day corporations, they have a lot of data and they need that data to figure things out. So again, data science, you do use machine learning, but then a lot of the work is not just machine learning. I would say most of the work is actually dealing with data and trying to gain insights from the data itself. So yeah, that's kind of a major difference between all four of them. If you guys, have any doubts, or is that clear? Or do you guys want me to explain a little more?
It's fine.
That's clear.
Clear, right? So yeah, okay, I'll go through the next slide then. These slides also I'll give after the session is over, so you guys can go over them. And yeah, no worries. Okay, now we're going to go over the types of machine learning. So there are four major types of machine learning that you'll see, which is supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. So we're going to start with the first type of machine learning, is supervised learning. Again, this is a name you guys must have heard a lot. Now, what does supervised learning mean? So it's a machine learning method in which models are trained using labeled data. Now, what does labeled data mean? So as I've shown in this example, as you can see, like there's a lot of data here. It's shapes. So you have a polygon and a square, and there's a triangle. And then the labels, like so the data, it's labeled, like so this is hexagon, a triangle, a square. So these are all labels in the label data. Now this data is put into your model for training, and then you use the test data for prediction and predict if it's a square, triangle, a hexagon, whatnot. So again, so it's a machine learning method in which models are trained using labeled data. That's the major word that you need to see. And then supervised learning can be used for two types of problems, which is classification and regression. So, right, this is how classification and regression looks like. So first, what we do generally is, before we even start the coding, we'll generally plot the data. So example, first you'll plot perhaps the data on the X and Y axis, right? So you can see that almost when you plot this, there's almost like two sets of different data. It's like almost separated by a boundary here. So that's classification. When you divide the data into classes, again, that's about classes. We will go over this a little later. And in regression, as you can see, when you plot the data points, they're not really into classes. You actually use this line. Now, this line is called the best fit line. Best fit line is, again, you did something. You did this when we were probably young. We in like 8th grade, 9th grade, when we used to get like X and Y coordinates, and then we plot those X and Y coordinates, and then we try to find out the line which kind of was the best fit for all of these points. That's quite similar as to what you do in regression. You try to find the best fit line to kind of reduce the error with the data points and the predicted values. Okay, so this is the first type of supervised learning, which is regression. So regression is supervised machine learning technique, which is used to predict continuous values. Again, the kind of major word here is continuous values. So for example, this example. So this is a linear regression example. So you are predicting the salary of somebody on the basis of their experience. So in this example, the salary is kind of the output and the experience is the input, right? So first, again, you like plotted the data points, fair enough. And then you need to plot the best fit line. Now, the line equation, this is the line equation. So does this look similar to something you have learned before? There's this like equation.
Yeah, y is equal to mx plus c.
Yeah, exactly. So it's just a simple line equation, y is equal to mx plus c. M there was the slope of the line, and c was the intercept of the line. So here the slope of the line is beta 1, and the c is beta naught. So yeah, so the output is salary. Then you have beta naught plus beta 1 into experience. The experience here is the input, and beta naught here is given 30K, right? So salary here is again is the output, but it is also called dependent variable, and experience, which is the input, is also called independent variable. Now you might wonder why that is. That's because salary is dependent on a variable, isn't it? Salary is dependent on your experience. Like the as you can see, like as the experience increases, your salary also linearly is increasing, right? So salary is dependent on a variable, which is experience. So it's called dependent variable, while experience is dependent on, well, nobody, right? So that is why it is called independent variable. So that's a very basic example of linear regression. Most of the work you're going to do is going to be a bit more difficult than that. But then, yeah. So again, the ultimate goal of the regression algorithm is to plot the best fit line or a curve between the data. So it doesn't have to be a line. It can also be a curve. But again, the whole point is to plot the best fit line or curve. And then you have three main metrics that are used for evaluating the trained regression model. So before I go, what do you guys think error is in regression? Error.
Deviation from actual value.
Okay.
Of the
So yeah,
predicted value.
Soham, what Soham said is great. So as you can see, this is the best fit line, right? So example, this is 10, so example, this is 10 years. And then when you see 10 years, this is what is being predicted here, right? But as you can see, there is a little bit deviation from the actual point, right? There's a little bit of difference, and that is what you call error. The deviation from the predicted value and the actual values. The difference between them is what we call error. So the main metrics that we're using is variance, bias, and error. So variance bias is actually a type of error. Now, what does variance and what does bias mean? So before actually going to variance and bias, I actually have to go over another concept, which is called underfitting, overfitting, and right fit. So let me go a little further. Okay. So do you guys know what overfitting, right fit, or underfitting is? Like, or you can just see this diagram and tell me, like, what do you think they are? Anyone?
The diagram represents the best fit lines.
Yeah. So that is correct, Satvik. So example, right? You have data, you have plotted the data, well and good. Now you need to kind of have a best fit line for a regression and a kind of a boundary for classification. So in a classification, we use boundary to kind of separate the two different classes of data. So as you can see in the overfitting criteria, in classification, the boundary is almost kind of going like this, right? It's almost curving to include all the points. And in regression, again, it's passing through almost all of the data points to make the best fit line, right? So you might wonder, that looks good, right? I mean, it's taking in all the values. So why is it bad? So the reason why overfitting is considered not as desirable is literally just because the model kind of starts to remember the data points. So when we train a model, first what we do is we separate the data set into training and testing data set. So why we do that is because, example, you're studying for a test and you studied everything in a notebook. And when you actually get your test, most of the questions you'll see is going to be a little different from your notebook, right? That's because they don't want to test you just what was in the notebook, because you might have memorized it, or it doesn't make sense to just test you on concepts or on questions that you already have done. So it will test you on new questions and new concepts. So it's similar in machine learning. What you do is first you take a data set, you divide it into testing and training, With the training data, you train your machine learning model, and after the model has been trained, you will kind of give it new data to be like, you know what, figure it out, tell me your predictive values. So as I was talking about overfitting, overfitting, what happens is the model almost starts to remember everything. It starts to remember the actual points. And now that's not really desirable, right? Because if you give it new data, it will start, the prediction won't be that good, because the model has kind of received so great accuracy, not because it's predicting good values. It's literally just because it's starting to memorize the data points, and that's not desirable. So that is why overfitting is not good, because then it's not going to give you a good prediction at all. Now, the opposite of overfitting is underfitting. Now, this is the underfitting example. As you can see, the boundary, it's not good. There's lots of points which are kind of outside of this boundary and kind of going into the other territory. And then even regression, the best fit line or curve is not good at all. Now, what happens in underfitting? When you're underfitting, the model is not good at all. Like, it hasn't done a good job of even training the model. So obviously, like, if you give it new values, it won't really perform well because the model itself isn't good. And then last but not the least is right fit. Right fit is actually exactly what you want. It's not like perfect as you would say it's overfitting, but then it's performing well enough that it hasn't started to memorize the data of the training set. So as you can see, there is still a little bit of data which is kind of outside of the boundary. Even here, there is like some of the data points which are not really on the curve. But then that's fair enough. Like, that's kind of the error we can manage. Like, we don't want it to be super perfect. So now that we kind of have a good idea of what overfitting, right fit, and underfitting is, we can go back to variance, bias, and error. Still then, do you guys have any doubts?
Actually, why is overfitting bad then? Like, how is it bad?
Okay.
Like,
so
it is
example,
memorizing the perfect balance, right?
Yes. So example, right? You're doing your questions, or you're doing your MCQs, right? And you're doing MCQs, and you've done so many times that you're almost like, example, you have R.D. Sharma. This is just a random example, and you have like questions there, and we've gone through R.D. Sharma so many times that when you see the questions, you can just remember the answer, right? And you can say that you've done a very good job. Like, you can almost remember the answer as soon as you see the question. But that's not desirable, is it? Like, you don't have to, like, it's not desirable that you just remember the answer right away, and it's you're not actually solving, right? So that's not desirable, because you've gone through it so many times that you have almost memorized the answers. That's not good. So it's similar in machine learning. You don't want it to memorize the data points fully, because then if you give it new questions, if you give it example, if you memorize all the answer well enough, but if I give you new questions, you might actually start to feel, you won't perform as good, because you didn't actually learn how to solve the questions properly. You perhaps started to memorize the answers. So that's similar in machine learning. The model is initially it was performing well, but then it started to almost memorize the data points, and then the model will be extremely biased, right? Like, it will be very biased because it's starting to memorize these points. And if you give it new data, it won't predict as well. Does that make sense?
Yeah, got it.
Got it, right? Okay. So I'll actually show you where. Okay, no worries. Where was I? Yeah. So what does variance mean? Variance literally means if you have a high amount of variance. Now, variance means the error you get while you use you're putting your testing data into the ML model, right? So high variance literally means high amount of error while you are putting in the testing data in your model. So again, that means it's overfit. Like, if you're getting a lot of error during the testing process, that means that the model has overfit, and that's not desirable. Bias is the opposite. So if you get a lot of bias, like bias again is a type of error. So if you're getting a high amount of bias, that means that you're getting actually a lot of error even during the training of the data set. So when you're training the data set, training the model with the data set, you're getting a high amount of error. It means that the model is underfit, meaning that it's not really performing that well. It's not even, the model is not even functioning that well, even just with the test training data. So that is what variance, bias, error means. It might sound a lot right now, but then these are just terms, so it's no big deal. Does that make sense? Bias, variance.
Yeah, it does.
Yeah, okay. So just remember, if you have a high amount of variance, if you have a high amount of variance, it literally just means that there's a lot of error during the testing phase of our machine learning model. So that means it's, overfit, it's not doing well. And high bias means there is a lot of error during the training of the data set itself. So the data, it's like the model, it's not really working out well for us, and it's underfit. So that's kind of the basic of regression. Now, this is again a very famous regression example, which is predicting the house prices of house with the input being the size in feet square. So again, this is, you have plotted the data points. X are data points. So initially, you plotted the best fit line, the pink line. And as you can see, like example at 750 here, you're predicting, initially you were predicting 150, and that's not really like close enough, right? The closer value is near to 200. So as your model will start to perform better, then you'll actually get the better curve. So this is the best fit curve. Again, it's not going through every single point. There is a little bit of error. As you can see, there's a little bit of error here. There's a little bit of error here. But then that is much, much, much better than initially what we were getting with just the straight line. So this is a very, again, famous example of predicting house prices with the size in feet square as input. So, okay, now there are two major types of regression, which is simple linear regression, which is what we have done till now. And we have also multiple linear regression. So the thing that separates both of them is that simple linear regression, there's only one output and one input. So in this previous example, as you can see, that there was only one input and there was one output. So there was, a simple linear regression, right? But in multiple linear regression, you have multiple number of inputs. Now, why is that? So example, again, you're predicting the house prices, but realistically speaking, the house prices won't just depend on the size of the room, right? Like size of the house, right? It depends on multiple factors. Such as perhaps the number of rooms, or if the house is close to a metro, if the house is close to, a hospital. There are multiple variables that go into predicting the house price. So that's kind of where multiple linear regression is used, because it has multiple inputs. So this is actually how the equation for simple linear regression looks like. Again, it's y is equal to mx plus c. They have just changed around the variables, but then it's the same thing. And then in the multiple linear regression, you can see there is multiple variables, multiple independent variables. Again, y is the dependent variable because y is dependent on the input, which is the independent variable, or x. So in multiple linear regression, you have one output, but there are like multiple inputs. And in simple linear regression, there's only one output and one input. So I believe we are done with the regression. So do you guys have any doubts with regression till now, till what I have shown you guys?
So it is not always the case that regression will always be a straight line. Like
No, definitely
it can
no.
curve through the points as well.
Yeah. So example, I showed you right in this. So oh, hello, I'm back. Sorry.
Yeah.
Where was I when I left? I did not notice the camera went off.
The types of regression.
Types of regression. Oh, no, that's
Types of
okay.
regression. There's like Tom asked
You
a
were covering
question
a doubt.
where he asked a question where will the regression line always not be a straight line? Can it be like curves?
Yeah, so it actually can be a curve. It doesn't actually need to be. Well, I'll share my screen first again. I'll start recording again. This is a mess. Did you
It's
answer,
recording.
Lenin?
It's still
It's
recording.
recording? Oh, okay,
Yeah.
fine. So you answered, Lenin, or should I answer the
No, you answer.
Okay. So you talked about if does a line need to be a straight line or not necessarily, no. So as you can tell in the first in this point, it says the ultimate goal of a regression algorithm is to plot the best fit line or curve between the data. So again, the point is that it is the best fit line or best fit curve. So a line is not always going to fare well for a specific data set. So sometimes line also works out. So again, in this example, we made a line instead of, initially we made a line, it didn't work out that well. And then as the model learned, it started to make this curve. So yeah, it doesn't actually need to be a line or a curve. Did I go over the regression types?
You showed this page.
I showed you? Okay, fine. This. Okay, so I'll start with classification then, guys. Do you have any doubts for me, more doubts? Okay, so I'll start with supervised learning, which is in classification. So classification is a type of supervised learning process of categorizing a given set of input data into classes based on one or more variable. So the main point here is the fact that in classification, you're kind of dividing the set of data into classes. Example, you have this input, variables, which is just data set. You have vegetables and then you have groceries and stuff. And then you put this into a model, and then later on you will see that there is vegetables and there is groceries. So the data set kind of got divided into two classes, which is vegetables, which is groceries. So this is a categorical output variable. Example, if we had fruits here as well, then we'll have three classes, which is vegetables, groceries, and then perhaps fruits. So again, the whole point of classification is to classify the data into classes. So classification in machine learning can require two or more categories of a given data set. So what happens is, therefore it generates a probability score to assign the data into a specific category. What that means is while the model is working, it will kind of give one specific perhaps data point, a probability, like what is the probability that you'll be a vegetable, what is the probability that you're a grocery, and according to that probability it will assign it a vegetable or it's a grocery, right? So yeah, so example of classification is perhaps spam, not spam, yes or no, disease or no disease, red, green, male, female, etc. So as you can see, there is classes, right? What happened in regression was we were kind of, the output was a continuous value. So it wasn't a class, it was a continuous value. While in classification, as you can see, the output is a class, right? So now this is a very famous example of classification, I would say. So you have a data of if a tumor cells in your body is benign or is it malignant. So what does benign and malignant mean? From what I know, benign literally just means the tumor cells you have are not cancerous. They're fine, they can be easily removed with surgery. And malignant means that the tumor cells you have are cancerous. So you basically plot the these are the inputs, like age and tumor size. You plot them, and you can see that there is almost like two different classes of data. So you have benign, and then you have malignant, and then it is kind of divided by this boundary almost. So the model has divided the data into these two classes. Yeah, so that's it for classification. Nothing much. Do you guys have any doubts with the classification?
No, it's fine.
It's fine, chalo. I'll move on. So that was supervised learning for all of us. Now we're going to do unsupervised learning. So supervised learning, as I told you initially, was the machine learning training method in which we used labeled data. So that means that the input, the output, everything is labeled correctly. But in unsupervised learning, the data which we are using is unlabeled input data. Now, you might wonder, like, why are we using unlabeled data? It doesn't really make sense. I mean, supervised learning is working just fine. Why can't we just use, labeled data? The problem is, most of the time we can't actually label data because it's so, it's humongous. You can't physically go and, categorize labels, and it's a lot of mess. So you're not going to get a data set realistically always that's going to be labeled. So that's why you need machine learning methods and machine learning, unsupervised learning for when you have unlabeled input data. So in unsupervised learning, there are two types of problems, which is clustering and association. So yeah, this is just an overview of what clustering and association is. So as you can see, these are just random data points, and yeah, it will kind of cluster it around, and these are like 3 different clusters, as you can see, of data, like black, red, and blue. So what happens in unsupervised learning is you just give the data to the machine learning model, and the model figures out, what to do without labels. So it kind of learns about the patterns, not, patterns itself, not necessarily from the labels. And in association, it means that if a customer purchase item 1, then you recommend them item 2. So yeah, let's go more into what clustering is. So clustering finds the commonalities between the data objects and categorizes them as per presence and absence of these commonalities. So the word we're using here is commonalities, right? So example, you have different types of news, right? So you can almost organize all these news as different clusters of news. So it's climate change news, weather report, rising gas prices, etc., etc. So you might wonder, why is news part of unsupervised learning? So the major reason is most of the news you see is web pages, right? You can't physically go and label all of these millions and millions of web pages. That's where we use unsupervised learning. So you have different clusters of news. So for example, you searched on Google about let me think. Perhaps you search about pandas, and you'll start to see after searching about pandas, you're getting a lot of news articles about pandas, perhaps pandas in China and what's happening with panda, or the panda news. So again, that is due to clustering. So there might be another cluster which says panda news. So if you search for pandas, you'll get panda news, and that's kind of how clustering works. So what, again, the word here is commonalities between the data points. So you just give the machine learning model the data, and without any labels, the model kind of tries to figure out the commonality between all of different points, and then it categorizes them into clusters of points. So yeah, that's clustering. Do you guys have any doubts with clustering? Am I going too fast? Tell me if I'm going too fast, I can slow down.
No, it is fine.
No.
No, nothing. Okay, fine. So yeah, that is clustering. Then you have association. Now association or association rule mining, you can call it whatever, finds the associations based on co-occurrences. Now what does that mean? Example, you are at a grocery store or you are at a retail store and you have bread and butter. So in clustering, what will happen is it will say that bread and butter is one cluster, because of the fact that they have a commonality between them. And what is that commonality? The commonality is perhaps that they are breakfast foods, right? So you will eat them during breakfast. So that will be one cluster. In association, what happens is, example, you bought bread. So you're also very likely to buy butter as well, right? So then if you buy bread, you're also likely to buy butter. So there's almost like a mapping. There's an association between two of them. If you buy bread, you're also likely to buy butter. So it's almost like a mapping is happening here. So that is what is association. Let me go more into deep the difference between clustering and association, because it might sound similar to you right now. So example, again, general details tour. Clustering algorithms may place white bread and brown bread together due to their similarities. So in this example, they're using white and brown bread. So let's Google that. So again, you're placing white bread and brown bread together because of the fact that they're both breads, or they're both breakfast food. So there's like one cluster. But in association, they will show a strong association between bread and butter because they're bought together frequently. So again, if you bought bread, there's a high association and a high chance that you will buy butter as well. So that's an association between them. So in more applicable terms, given the transaction data, clustering is used on samples, rows. In association or rule mining, association rule mining is used on variables. So let me show you guys a very good example. Again, this is a table. There are 4 customers. They have bought milk, bread, butter, cheese. And these are all, this is like a customer 1 has bought milk and bread, and so on and so forth. So what are the clusters here? Do you guys have any ideas? Like, what do you think the clusters here will be in this data set? Any ideas at all?
Is it like division?
It is in a way division. Okay, let me show you. So clusters here will be, okay, example, you have only 2 clusters here because the data set is so small. But okay, so cluster 1 will be customer 1 and 3, and cluster 2 will be customer 2 and 4. I'll show you. So the green is one cluster, the pink is one cluster. So when we talked about clustering, we used the word commonality, didn't we? So commonality means there is a similarity between customer 1 and 3. And what is that? That they have bought similar items. So as you can see, both customer 1 and 3, they bought milk together, and customer 1 and 3, they bought bread also. So that's a cluster, right? Because they have a commonality. They have bought the same things from this retail store. And then you have customer 2 and customer 4. Again, there's a commonality between customer 2 and customer 4 because they have bought bread and also cheese. So that's great. So that's another cluster. So, you're dividing these into 2 clusters because of the fact that they have a commonality between them. And that commonality is the fact that they have bought similar products together. Does that make sense for clustering?
Yes.
Yes. Okay. So again, clustering is just for that they have commonality. So customer 1 and customer 3, they have a commonality between them. Customer 2, customer 4, again, they have a commonality between them. Now, association is a little different. Association here, you will have suggest association between products, that is variables, that are more likely to be bought together in the future or in the present, whatever. Then you have association 1, which is milk and bread, and association 2, which is bread and cheese. Now, what that means is you have these 2 association, milk and bread. So if you see if you see milk, you can see whenever milk was bought, butter was also bought with it. So there's a high association between them, right? The data set is quite small, so it's only like only customer 3 that is bought it together, but chalo koi baat nahi. So whenever as you can see, like whenever that somebody bought milk, they also bought butter. That's one association. And the other association is if a person bought bread, they also bought cheese with it. So as you can see, like they are more likely to be bought together, or they are in the future, they're more likely to be bought together. So that's clustering. So sorry, that's association. So sorry. So association here is milk and butter because they're likely bought together. Like the customers bought them together, and bread and cheese are again association because again the customers bought them together. Does that make sense? Like association, clustering, the difference between them. It might sound confusing. It definitely looks confusing to me as well. But if you guys just, I'll give you this after the session gets over. You can also read up on articles with the difference between them. But whatever I've taught you, does that make sense? Like something went into your head between like what's cluster, what is
Yes, Divi,
association?
kinda, I can understand.
Kind of. So that's, you know what, kind of is good. Like it took me like a while to figure out initially what association and clustering meant. But with one sentence, I'll say clustering is kind of you're dividing clusters because of commonalities between them. So humans have commonalities. So the customers were divided into clusters because of the commonality. And an association, there's almost like a mapping. That's how I imagine it. Because if you bought milk, then there's also, you also bought butter with you. If you bought bread, you also bought cheese with you. So that's association. Yeah, so that's actually unsupervised and supervised learning altogether. Do you guys have any doubts till now? Okay, I'm going to assume no doubts. So do you guys want to take a break? 5 minutes? I mean, we don't have much left, but then I've been going on for a while now.
Sure.
Sure? Okay, 5 minutes break. I'll get started again. So we covered supervised and unsupervised learning till now. And the third type of machine learning, I would say, is reinforcement learning. So reinforcement learning is a machine learning training method which is based on rewarding desired behaviors and punishing undesired ones. Now, what that means, for example, you're training a dog, right? You're training your dog how to sit. And whenever your dog sits, you give him a treat. Or like you tell him he's a good boy, or you smile, whatever. Like you give him a desired behavior, right? And if he doesn't sit down, then perhaps you punish him, like you scold him, or you do not give him a treat, whatever. So that's how you train a dog, right? Like you give, whenever he does something desired, you give him, you kind of reward him, and if he does something which is undesired, you kind of don't reward him. That's similar as to how reinforcement learning works. So in general, reinforcement learning agent, the entity being trained is able to perceive and interpret its environment, take actions, learn through trial and error. Again, the word here is trial and error because you're kind of training the model as it goes. So I'll show you a good example in the next slide. So this is how kind of reinforcement learning works. There is this agent. It can kind of interact with this environment. There is an interpreter, which is you most of the time. So whenever the agent does something correct, you give him a reward. And if he does something wrong, then you kind of don't give this a reward. So this is an example. You have this, you have this machine or you have this robot. So it's an environment. The environment has fire. It also has water. So initially you have your robot, it isn't really trained, it doesn't really know anything, it's new to this world, if you will. And it sees two places, it doesn't really know where to go. So initially it will just go to the fire or it will go to the water, like it will just go randomly. So if it went to the fire, that's not good, right? So you give him like a penalty and you give the penalty as points. So for example, you give him his minus 50 points. So now he will know, the robot will know, okay, like when I went close to the fire, it gave me demerits, it wasn't good. So next time, he won't go there. He will go to the opposite direction. So this next time when he goes to the water, you can give him plus 50 points. So you're telling him, okay, like going to the water is fine. So it's a very basic example. A very good example of reinforcement learning again is a rover. So like a Mars rover, it's for example. So Mars rover example, it's going to one specific, is perhaps going towards east. Okay, and you don't want him to go towards east, you want the rover to go towards west. So you'll start giving him like demerits, or you'll give him minus 50 points, for example. Then it will be like, okay, like it really can't go in that direction. Then it will turn and go to the other direction. So then you'll give him plus 50 points. And then, that's how you maneuver it. Like whenever it's going correctly, you're giving him plus 50 points. When it's going not in the correct direction, you're kind of giving him minus 50 points. So that's really it for reinforcement learning, nothing much. Personally, I haven't encountered reinforcement learning a lot. I haven't done much in reinforcement learning. I would say definitely the most work you'll do is supervised and unsupervised. So yeah, that's really it for reinforcement learning till now. Do you guys have any doubts for reinforcement learning?
No, it's fine.
It's fine, right? It's very easy. It's a very easy concept. But yeah, that's it for reinforcement learning. Now, the last type of machine learning method is semi-supervised learning. So if you actually go and learn about machine learning, a lot of places don't actually talk about semi-supervised, but then it is a type of machine learning, which is semi-supervised learning is a type of machine learning that kind of falls in between supervised and unsupervised learning. Now, what that means is that only a small amount of data is labeled and the rest of the data is unlabeled, right? So you have a big data set, you have only labeled like a few of the data, like a little bit of the data, and the rest of the data is unlabeled. So you might wonder, like, what's the point of using semi-supervised learning? Again, you have so much data, you can't physically go and label every single data point. So perhaps you will label a little bit of the data, and rest of the rest of the data you leave unlabeled. So again, this is useful mostly because there is a large amount of unlabeled data, but it is also it's extremely expensive and difficult to label all of it, and most organizations don't have the time or energy or even the money to go and label the data. And it's a lot of tedious work as well. So that's kind of where you will use semi-supervised learning. Example, you have this data, it has fruits, like it has a apple and a mango, sorry, not a mango, sorry, apple, banana, and orange. And, the orange and banana are partially labeled. So you'll put this into your model. Then, for example, it will see a pineapple. It will be like, sorry, it will see an apple. Oh my God. It will see an apple. It will be like, okay, this is not labeled. And then it will predict it's an apple. Fair enough. Yeah, so good. Another example of semi-supervised learning is internet content classification. So again, like, labeling each web page is very impractical. It's unfeasible. You can't really do it. And that's where semi-supervised learning is also used. So apparently, like, Google search algorithm is a variant of semi-supervised learning now, which is kind of used to rank the relevance of a web page for a given query. So example, if you go and Google, like, perhaps anything, perhaps you Google about a movie, right? You see all the web pages ranked. So I believe that's where semi-supervised learning is used. Now, I'm not completely sure how correct this information is. I don't know if Google has released this, but then, yeah, that's where I've heard semi-supervised learning being used. So that's it for the last type of machine learning, which is semi-supervised learning. Do you guys have any doubts with semi-supervised learning?
No, it's fine.
Okay, fine. Now, this is kind of the last portion of this whole seminar thing. This is going to be about data analytics. Now, realize when you're working over a project, or if you're working on an ML project, it's not just coding the ML models. A lot of times, it is actually also working with data. So data analytics is the process of analyzing raw data in order to draw out meaningful and actionable insights, which are then used to inform and drive smart business decisions. Again, the word here using is smart business decisions. So a lot of organizations use data analytics most of the time you don't like coding is like you don't need to be the most proficient in coding to handle data analytics in comparison to the other fields in machine learning. A lot of the work of data analytics is just trying to find meaningful data insights from the data itself. So data analytics basically helps you to make sense of the past and also predict future trends and behaviors. So rather than just basing your decisions on guesswork or your gut feeling, a lot of organizations will use data analytics to make informed decisions. So you have data extraction, data transformation, data loading, data analysis, data visualization, all that stuff. That's kind of what encompasses data analytics. Now, okay, data analytics lifecycle. So what do you like? What comes to your mind when you think of a life cycle? The word itself, life cycle. Anybody?
It's like beginning, process, and the end of something.
Yes, exactly. So what data analytics lifecycle means is what is a life cycle of a data analytics project, or even a machine learning or data science project. Like most of the process looks pretty similar. Now the thing with data analytics life cycle is there is no fixed life cycle. You have, I feel like every organization follows a little bit different life cycle approach. Every person has a different life cycle approach. So this is a life cycle that I learned in my course. So the step one is objectives. So that is just defining your business objectives. So you're in an organization, perhaps your business objective is to increase the sales next quarter. So that is your objective. That's a very realistic objective as well that will be used in organizations. Then what you do is you gather required information. So you start researching what are the information that you need to work on this data analytics project. So that is talking to people and kind of figuring out what you need, thinking what you need. A lot of it's just literally thinking what you will require. And then determine appropriate analysis method. So again, this is just thinking like whatever you think that was going to work. Then you're going to clarify the scope of the work and identify deliverables. Again, so objectives is literally just working even before you start working code-wise or data analytics project. It's literally just thinking what you need to do. So you actually go into your project very well prepared because you have a very defined objective and everybody's extremely clear as to what they have to do. Then the next step is data understanding. So you start to collect your initial data and identify data requirements, determine data availability, explore data and characteristics. So again, working with data is a very big part of just working in data analytics, machine learning. So I'm actually doing a research internship right now. Literally the only work we have done till now is just data collection. And since it's a research thing, we are collecting data through like other research papers and other like literature reviews. So we're literally going through multiple research papers and just gathering data from the tables there. And it's an extremely tedious process, I would say, but it is an extremely important process as well because without data, we can't really do anything. So again, the second step is to just collect initial data, kind of explore this initial data and what characteristics. Then you have data preparation, which is gathering data from multiple sources. So you'll start to see multiple sources, you'll gather data from there. Then you will cleanse, format, blend, and sample. Now, what does cleanse mean? So, unfortunately, a lot of the data we get in the real world, it's not really clean, is the word we use. What does clean mean is, clean literally means that a lot of times the data is missing, or the data is not formatted correctly, or the data is corrupted, right? Because realistically, people don't store data that well. A lot of times you will gather data from multiple sources, like multiple companies or multiple people, and everybody, doesn't store data that well. So your initial step is literally just to clean and work with the data and make sure that your data is good before forwarding on. Then again, you format the data, you change the format to make sure that it kind of looks like what you need it to look like, then blend and sample. Now, the step 4 is exploratory analysis, or it's also called EDA, which is exploratory data analysis. Extremely, extremely important part of the life cycle. So this is where you develop the methodology, meaning that you can develop a methodology of what you're going to do, all that stuff, and then we determine important variables. Now, what does it mean to say determine important variables? What do you guys think? Like, what do you guys think when I said this, like, determine important variables? Anybody?
The variables which matter for our data prediction. Like
Yes,
something like that.
exactly. Exactly. So, example, again, you have a very big data set, but then it has like 40 features. Now, what does 40 features means? There is like 40 columns. And that looks, you might think, oh, that's good, right? You have a lot of data, like that's good, right? But no. For example, like if you tell somebody a description of some celebrity in like 5 or 10 features, right? They might be able to recognize who that is. But if you tell them like 40 features, like blue eyes, and you go on and on and on, then person is going to get confused, right? Like 40 features, that's a little too much. That's same with machine learning. Your model, you don't need 40 features or you don't need 30 features for it to work. A lot of times what will happen is it will start to overfill because there is just so much data. You don't want it to overfill. You don't want it for that to happen. So what you do is you kind of identify the important variables that actually affect your output. So not every variable or not every column is going to have the same amount of impact in a model, right? So for example, let's think. Example, you want to predict the house price, and you have very important features such as, number of rooms and perhaps, the size of the house, if it's close to, school or not, blah, blah, blah. And then you have a very irrelevant feature. For example, the number of windows or the number of lights. Like, it's a little irrelevant, right, to the house. It matters to a house, but then it doesn't really increase the price of the house. That's an irrelevant features. So what you do is you kind of remove those irrelevant features from your data set and just only retain the most important variables that you need. So you do this a lot of times do with common sense. So a lot of times you might just remove the columns because the help of common sense that you use. And one other way is a correlation matrix. I'm not going to go super deep into correlation matrix now, perhaps in the next session. But yeah, correlation matrix is a way that you use to kind of identify the most important variables that you need for this model. Is that clear? Like, does that make sense?
Yeah, it's fine.
Yeah, okay. So now the next step is to build your model. So you build your model and then you assess your model. Assessing is literally just means like you see the accuracy, the F1 score, all that stuff, And then you have validation. Validation means you evaluate your result, you review the process, and you determine your next step. So like, for example, you didn't get the desired result you want. Perhaps you got a really low accuracy, like perhaps you got like 65% accuracy. But that obviously means that something went wrong. So a lot of times what you do is you figure out what to do next. You'll figure out what went wrong, where it went wrong. And then you might actually even go to the past steps to do steps again. This happens a lot, especially when you're building a model. A lot of times, like you initially put random parameters for your model, and then you might say, okay, it's not really doing that well, so you go and change things and then come back and try to figure it out. So a lot of times in machine learning, deep learning, it's just figuring out how to change the parameters to make it a better model. So as you can see, these are 4 steps. Like you can go back to certain steps if you're not getting your desired result. So yeah, after validation, your last step is to visualization and presentation. So you've done everything. Your model is working fine. You've also gotten a very good, analysis of your data. You understand your data. Now, what you'll do is you communicate the results. So this could be a research paper. It could be, a PPT presentation to your colleagues. And then you also need to determine the best method to present insights based on analysis and audience, craft a compelling story, and make recommendations. So you've done everything. Now you'll just present it to people who needs to see this, and yeah, you're done with your data analytics project, data analytics lifecycle. So yeah, that's very simple. This is a very good methodology what you'll follow while you're actually making a model or you're actually working on a project. Yeah, that's fine. Now, is everything clear till now? Do you have any doubts? Okay, I'll assume no doubts. So yeah, this is the second last slide, which is type of data analytics. So you have 4 main types of data analytics. You have descriptive analytics. Now, what that means, descriptive analysis basically deals with what happened in the past. So you'll take your data, you'll try to figure out what happened in the past. You'll make graphs and diagrams and stuff like that. And descriptive analytics is just working out what happened in the past. Diagnostic analytics deals with basically why did it happen in the past. So you have done describing what happened in the past. Now you try to figure out why it happened. For example, the sales didn't go that well the last quarter. So you'll try to see why did it not go, and you'll try to figure out, you'll try to diagnose a problem there. And then the next is predictive analytics. What that means is it deals with what will happen in the future. So yeah, again, you're dealing with what will happen in the future. That's predictive analytics. And the last is prescriptive analytics. So that deals with how can we make it happen in the future. So you know what's going to happen in the future, but like how can we make it happen now? So as you can see, like as you go rightwards, the kind of difficulty definitely increases. And these are 4 main types of analytics that you're going to see and work with. This is the last slide now. This is the data visualization tools that you'll see. Again, data visualization is a very, very big part of data analytics. A lot of times you're actually going to do this more than you're going to work with machine learning, I would say, especially if you want to go into companies. So in Python, you use matplotlib and seaborn libraries for data visualization. In R, which is again a programming language, some of you might be learning like probability and statistics, right? That's where we use R. So R is a programming language that mostly statisticians use. People also data scientists also use for data visualization and statistics, probability, all that stuff. So in R, you will use ggplot2. And there's like 2 applications websites, Power BI and Tableau. So Power BI is by Microsoft, I believe, and then Tableau as well. These are actually just, you have Power BI and Tableau literally just for data analytics. So making graphs and figuring out what happened in the data and stuff like that. So you don't want to work with, if you don't want to work with code, you just want to just work with the data and you really don't want to make machine learning models, then that's where you'll use Power BI and Tableau. So this is actually a dashboard that Lennon here made. Let's thank Lennon for giving this screenshot to us. So yeah, he's just made this dashboard in Tableau. So there's a county, I believe, in Washington House, and he's made the, all this like graphs and stuff without any code, by the way. So if you don't want to work with code, Power BI and Tableau is what you'll do to work without code. And that's actually it. That's it for intro to machine learning. I hope you guys understood something and had a good time. Honestly, that's it from my side. Do you guys have any suggestions for me or for Lennon or for programming department in general?